Hello chemistry students, I'm here to introduce you to Unit 6. In Unit 6 we're going to look at covalent bonding. In video 6.1 we're going to introduce that topic. The goals for this video are to explain the properties of covalent molecules, explain how covalent bonds are formed, comparing covalent bonds and covalent substances to ionic bonds and ionic substances, to identify pairs of atoms that will form covalent bonds, and to recognize that we can have single, double, and triple covalent bonds. So let's get to it. So on the left you see the list of the properties and description of what we've learned are true of ionic compounds. Hard, brittle, all this stuff. And we're going to contrast that with what we will see in a covalently bonded substance.
Yeah.
Okay, so let's
start with the first one with hard. Ionic substances are hard, think of table salt, but covalent ones are usually soft. And if you want to think of like potatoes as a covalently bound mesh of molecules, they're soft and squishy. As long as brittle, so that kind of goes under that, so they're soft. Easily ground, I guess, is a good word for it. They're easily ground. And the next one is conduct electricity. These do not conduct electricity, so not conductive or non-conductive. Their structures...
Even when they're dissolved, they're not conductive.
Yeah. Their structure... Oh, we forgot underneath brittle. Usually also liquids and gases as well. They're not always crystals or hard. They are sometimes gases and liquids. So,
where almost all of the ionic substances are solids, and
solid
there are
crystals.
A few gases, but...
liquids and gases. The form isn't always crystal. It can be, like we said, liquid and gas as well. So I'm going to draw an arrow up there. It can be, but not always. And then they have a low melting point. So instead of a high, they have a low melting point. They're not made of ions. They're made of molecules or individual atoms combined together. They don't transfer their electrons. We talked about how they transfer. Now they share electrons. So they share their electrons. Like ionics, though, they do go for a complete octet role. So that is a similarity between them. They both complete their octet role to be stable.
They just do it by sharing instead of transferring.
Yeah, instead of stealing from their neighbors, they share with their neighbors. And lastly, the high electronegativity difference for ionics that form the actual ions are now low electronegativity differences, abbreviated EN. And that's how covalent bonds are different from ionic bonds. And we're going to show you some examples in the next couple of slides of how they look and how they act. Alright, we came back to the first slide, not that you know, because we missed a key point. Ionics are between metals and non-metals, where covalent bonds are made up of a non-metal to a metal, non-metal to non-metal. And Mr. Ferguson, take over.
So, if it's all non-metals to other non-metals, we would expect it's a covalent bond.
Alright, so the first thing we're going to talk about is, actually show you how covalent bonds are formed. So looking at the top here, you can see that we have a hydrogen atom, and it has one electron and one proton, and we get that from the periodic table. And we're not happy because we want to try to complete the octet role, but since hydrogen doesn't have the room for 8 electrons, it completes its octet role just by filling in 2 electrons.
We would call that the duet sort of sub-rule.
Yeah,
if you're on the first energy level, a duet is as good as an octet.
Yeah. So then it wants to be like helium, and that's why helium's over here. Helium has 2 protons, 2 electrons. That's why it's considered a noble gas. So elemental hydrogen, to become stable, will find another hydrogen and combine with it, and it'll share its electrons. And in sharing the electrons, they now both have 2 electrons most of the time. So they share them, and we draw them much like down here. That's known as a Lewis dot image, which we're going to talk about in Unit 5 or 5.5, I think.
Right, and this one is just a line bond where you write the H's with the
there's a
line in
special
between.
name for that, like the click or something. It's something weird.
But the line would represent the same thing as a shared pair
Yeah.
of electrons. It's a single covalent bond
So-
between them. So the electrons actually spend
Equal
the
amount
majority of their
times.
time in between the two nuclei. So this positive nucleus is pulling on the two electrons. This positive nucleus is pulling on the two electrons, and that creates the force that holds up. It's like two little toddlers fighting over a toy.
They're
Neither
still
one
like
will let go.
they're
of
no
it.
longer like magnets because they don't have charges per se.
Right.
Each individual hydrogen does not have a charge. They have
No,
what are known as
overall
partial
charge
charges.
is neutral.
Yes, but now they share them. So the next thing I'm going to take a look at are those things I mentioned in class, at least in my class, about the diatomic elements. I told my class that there are 7 of them next to each other that form a 7. So if you see the laser pointer over here, it's that 7 plus hydrogen. So we're going to write them out real quick for you. There are 8 total diatomics. It's hydrogen, so just H2, and then fluorine, which is F2, and then chlorine, and then bromine, and iodine, and lastly, astatine as well would form the same type of diatomic because it is still a halogen / metalloid. So those are your diatomics.
Well, we also have
Oxygen, sorry, and
N2.
nitrogen. My bad.
NO.
Yeah, so if we ever say the words oxygen, nitrogen, bromine, elemental bromine like that, we want you to know that it's O2, and we're not going to always say O2, F2, Br2. It's something like naming. You just have to be able to do it in the end.
As soon as you get any two atoms of those elements together, any collection of those atoms together, they will, to be stable, pair up and covalently bond with one another. And so they exist as stable diatomic molecules.
Every
But
atom,
they're still considered elements.
yeah, every element kind of does this in its own way, but these are the main ones we want to learn. So at this point, let's go take a look at some examples of what these different ionic and covalent things look like when put next to each other. Well, I was wrong. We're doing bond types, or number of bonds first. These are going to come up more in, again, 5.5 when we talk about Lewis dots. You can see 3 examples of Lewis dots right here. We're going to tell you how to find those numbers and how to make them. But right now, we want to get you keyed in on the terms single bond, double bond, and triple bond. Covalent molecules can form different types of bonds. And single bonds are just the sharing of 2 electrons. So they only share 2 electrons, whereas a double bond now has 2 bonds. So it has 4 shared electrons. And due to this, also another little note to be taken would be the fact that the shared electron, since there's 4 of them, are actually a smaller bond. So that's something to take note of. Not really
It's
hugely
stronger,
important.
too.
It's smaller, it's stronger. It vibrates faster if you look at it on a rotational vibrational scale.
And
But
it's
again, that's
harder to
all.
break.
Yeah, that's just later and more advanced chemistry. And right now, we don't care about that. And then lastly is the triple bond. You see there are 6 shared electrons between them, and you can also notice that hydrogen, oxygen, or nitrogen are some of those diatomic elements we talked about. So at 6, they're shared as well, and they're even smaller still than a double bond. So that's the type of bonds. And now, if I believe I'm right, we're going to go and take a look at the different types of compounds, ionic and covalent, next to each other. So I was
I'll
right.
let you do this.
So I was right
this
this time.
part.
I'll use my fingers.
Okay.
So I was right this time. So let's take a look at the 3 ionic compounds we have first. We saw some before. Right here is our crystal structure. You can see it's very ordered. It looks shiny. Not that that really matters, but it looks ordered. It's hard. It's brittle. It conducts electricity if it's dissolved, and it's
Right.
not made up of carbon, hydrogen, and oxygen. So what do I mean by that? Well, if we take a look at the next one here, this starch, which is in potatoes, as you see, you can see kind of that it's made of carbon, hydrogen, and oxygen.
3 nonmetals. I
3
believe.
nonmetals, which we did forget to mention earlier.
Yeah, that was an important point that we need to mention. We learned that if it's a metal and a nonmetal, you're going to expect an ionic bond.
So we're going to make that point, and I think we'll have you write
Okay.
down the next slide.
And if you see more than one nonmetal, and that's all that's in the formula, you can be pretty sure it's a covalent bond.
Yeah, so, and the next one, NaCl, that's a metal to a nonmetal. So that's table salt right here, metal to nonmetal, salt, table salt, NaCl. It's
you can see the crystals of it all over the inside.
Yep, so when you come right back out of solution. And then we have, here's another one, copper sulfate. You can see that it's nice and crystal looking. It's a nonmetal and a metal put together. So again, we would assume that would be another ionic compound. And then we look at these next ones here. We have acetone, CH3.
No, let's look at this. Let the students look. What do we got?
That's 3 different nonmetals, carbon, hydrogen, and oxygen.
It's a liquid.
And it's a liquid, so it's definitely
so it's not made of crystals.
So that'd be a very good indicator. So that one's liquid. It turns into a gas very easily too. If you put acetone out on the table, you'll smell it.
Evaporates.
So they're volatile. They're very easy to smell. And then the last one here is vegetable oil, which doesn't have a formula, but it's primarily carbons and hydrogens strung together in long chains.
Liquid.
And it's liquid and also flammable. So that's something we need to know about covalent bonds.
Okay, so we're going to show you a little video clip of a demonstration we did earlier in the year and see if we can figure out what type of bond is in the molecule that's going on.
Based on the properties present.
There's a soap bubble going to go up in the air. There it goes. All right, so what kind of bond was present in the substance in the soap bubble?
Well, let me see. We were dealing with a gas, and it was flammable, which means it had a low melting / boiling point, and it was volatile. So I'm going to guess it was some type of covalently bound molecule, and in this case, it is methane, to my knowledge.
Natural gas.
So natural gas. So right there you go. We have our covalent bond. You can see some properties of it in that short little demonstration. But I guess we'll talk more about these tomorrow in class then. Have a good night.